Okay, welcome back to part two of my introduction to Westpac Mark IV. In the last episode, we thought about the signaler pressing the entrance button and it being registered in the SR start relay, and then pressing the exit button and that being registered in the DR destination relay, both of which remain energized until the push button interlocking resets itself. And in order to remember the start and finish the route once that interlocking has reset, we have a UER, a route entrance relay at the beginning of the route, which has been latched up, and a route finish relay at the end of the route, which has also been latched up. So we know where the route needs to start from, we know where it needs to finish. Now we need to set the route and lock it in between the start and the finish, or the entrance and the exit. So let's have a look at how that's done. And if you thought the last one had some complicated circuitry, this one is going to stretch your mind a little bit. So as I say, the signal has selected the entrance. The SR relay is recording the start of that route in 8GM signal main set. They've also selected the exit, and the DER is recording that, and that is in 6SGM. Now the PBI has got that relay called the DJR, and that holds the whole thing for a period of time to allow the route to set. If not, it will restore the system. And as I mentioned, the entrance is stored in the UER and the exit with an UFR. Now this is where it's important to know how the layout is laid out on the schematic of sets. It is not relevant which way the route is being set, it is left to right on the schematic. And that becomes important because in some of the circuits we're going to look at, the B50 or positive 50 volts will be on the left-hand end of the circuit relating to the schematic, and the N50 or negative 50 will be on the right-hand end. Convention is that B is used for positive, as in battery, I think, and N for negative. So we have our route from 8GM. It goes through the O unit, goes through 201 and 202 points, through 3GO unit, and reaches 6GM, where the route will finish. So we need to find that route. Whilst the signaler knew the route they were setting, the interlocking doesn't. And so the UZR circuits are used to test what routes are available and possible within the interlocking. Each UZR is fed from the set to the left and the set to the right, with B50 from the left and N50 from the right. And if the conditions are not are met, then the UZR will be energized. And then as the route is set, each of the UZRs in turn will be dropped. We'll have a look at how that happens. And the action of dropping the UZR enables that section of the route to be locked. So here's just an example of three sets, all with a UZR and all with a CUR, a latched relay, which needs to be picked up. The CUR is the calling route relay. So if in the middle set, the UZR will be energized because the set to the left, the CUR, is de-energized, so the CUPR is de-energized, and in the set to the right, the CUPR is de-energized. Similarly, in the third set, the UZR will be energized. However, if we look at the first UZR, it has got a negative N50 feed from the middle set over CUPR de-energized, but because the entrance has been registered in the left-hand set, the UER is energized, and that cuts the B50 feed. So the UZR in the first of our track sets will not be energized. What that means is that a feed going left to right in the order of the schematic can feed from the signal set at the start over UER energized, and it will feed all the CURs in the root. However, the second and the third CUR coils are bridged out by their relevant UZR contacts. And providing it's going to the destination and the root finish relay has been latched up, then a feed, the N50 feed from the right of the schematic, will feed to the first of the CURs, meaning the first CUR will pick up, only one coil being in series at a time. Now, the action of the CUR picking up will cause the feed to the UZR in the second set to be dropped. That means that UZR will drop, putting the second CUR pickup coil in series with the first. Two coils in series will mean they won't actually operate. However, in the first of the sets, the CUPR will pick and the LUR, which we'll come to in a moment, will unlatch and latch down, and that will bridge out that CUR coil. With the first CUR coil bridged out, then the second one will receive the full voltage, the 50 volts from the left, negative 50 volts from the right. And the process can repeat with the CUR in the middle one energizing, latching up, the CUPR picking, the UZR in the third one dropping, the bridging out around the third CUR coil being removed, and the bridging out of the second coil being put in place. And similarly, the CUR in the third set will now pick up. Eventually, the LUR will unlatch, and that coil will be bridged out. And at this point, you can see we have B50 on the left, 50 volts positive, connected to the N50, 50 volts negative on the right. At that point, you might expect a fuse to blow. Well, this is where the circuit gets clever. And we'll have a look at it on the next slide, or two. So first, let's just look at a real example from our layout of the UZRs. One of the things you can see is that the UZR circuits include diodes. That is why it is important that the B50 is on the left-hand end of the schematic and the N50 on the right. Otherwise, the circuits would not work. The UZR circuit at the top starts at the left-hand side, feeds through to the first of the sets, and because the NCUPR, the normal CUPR, is de-energized, it will feed through the NUZR, feed through into the second of the point sets at the bottom, and pick up a negative feed over that set's RCUPR and NCUPR, both de-energized, bottom left of the screen. Or it would, except for the fact that the UER is energized in 8GM. So I've drawn the circuit that would have been made in dotted red to show that it would have happened, but when the UER energized, then the UZR, NUZR in 201 WS2 was de-energized. We can look at the second of the UZR circuits, starting in 201 WS2, goes over the CUPR down, feeds into 202 set, over the NUZR, and then out through all the other sets until it reaches 6 SGM, where it picks up a negative 50, N50, over the DR energized. So that's the destination. So that's our UZR circuits. They look a little bit complicated because they all overlap, but actually each one is quite a simple circuit. It's looking to the left for a B50, which is available if that part of the route has not been set, and it's looking to the right for an N50, negative 50, and that's available if that part of the route has not been set. Now we move on to the CURs. And as before, we have all of the CUR pickup coils connected in series with a core which is called the CUR pickup core, not surprisingly. On the left-hand end is the feed, B50, and on the right-hand end is the negative 50. The first of the CUR pickup coils would have been bridged out if the NUZR was energized. But as we saw on the previous slide, that has dropped. So the NCUR pickup coil for 201 is in the circuit. However, the NUZR in 202, bottom left, is energized, and so the pickup coil is shorted out. That means that the full voltage is available to latch up NCUR in 201, top right. Once that has latched up, as we saw before, it is going to cause the WZR in the next set to drop. That will put the next NCUR in circuit. And once the LUR has dropped in the first set, the purple around that coil will be made to bridge it out, and so the 202 NCUR will be the only coil in the circuit, and that will latch up. Once it has latched up and the NLUR in 202 is unlatched, then the N50 from the right at the bottom will be able to flow all the way through back to the entrance set to 8GM. And in 8GM, there is a relay in series with the CUR pickup line called the FKR, the finish indicating relay. And that is designed so that when the circuit is complete and all of the CUR pickup coils have been shorted out, then that relay will energize to indicate that the route setting is complete. And in the next video, we'll have a look at how the FKR is used to reset the push button interlocking. But for now, we also need to consider how the LURs, the locking route relays, will be de-energized or released. Because the system works on having the two latched relays recording each section called and then locked. The CUR is latched up when the route section is called, and the LUR is latched down when the route section is locked. And it is that combination which prevents opposing routes being set and controls points and preserves the safety of the route. In the entrance set, there is also a route normal relay that says that the entrance set is in use for the normal direction. One also exists at the exit set, and that was set when the finish relays was picked. However, for the entrance, it is set when the first of the route sections is called. So when 201 point unit NCUR picks, it feeds along the UNR line back and picks up the UNR in the entrance set to set that set's direction. And that prevents opposing routes being set in future. You'll notice that it's picked up whilst the SR is still in use. We now can move on to the LUR release line. I told you this was going to take a little while to get through. We now have an N50 feed leaving the entrance set. It feeds out over the SR, the start relay, the UEPR, the route entrance repeat relay, and the UNR, the route normal relay. So it is proving that the opposing route locking has been applied within 8GM. We just looked at that on the previous slide. The LUR release line then feeds through each of the sets in turn, and when it reaches a set which represents part of the track, such as 201 point set, top right, then it will cause the NLUR there to release. Once it has released, then that feed then passes on to the next set. Each time it waits for the NCUPR or the RCUPR if it was in the reverse position to pick to enable it to unlatch the LUR. So the sequence we see in each of those sets is that the UZR drops, the CUR picks, and then the LUR releases. And in the next set, the same process. The UZR drops, the CUR picks, the LUR releases. And if there is a fault, then it is not difficult to go through and look at those three relays to understand where in the route setting process the fault is occurring. It could be the CUR is picking, but the LUR has not released. That would incriminate either a fault in the LUR release line or more likely a fault in the NCUPR contact or its feed. So we have gone through now and we have set the route. We have energized and latched up the CURs. We have de-energized or released the LURs for the whole of the route. What do we do now? Well, we need to move the points. So let us imagine that one of the sets of points was in the reverse position, but for our route, they need to be normal. So the first thing is that the circuit detects the track over the points is clear. It then checks that the points are not locked or called in the reverse direction. That's the RCLCR and the RCLCSR. If you're interested in those, we'll have a look at some of the other circuitry later. But for the moment, we can assume that they are telling us that there is no reverse locking up in place. However, the points are in the reverse position. The RLPR is energized. The NLR and RLR are a pair of latched relays to record which position the point should be in, either normal, NLR picked up, or reverse, RLR picked up. And that feed then enables us to energize the WZR, the point special relay. And that requires the key, top right, the point key that is, to be in the center position, energizing the CR relay. So providing the points are in that, the point key is in that mid position and they're not locked reverse, then when the call is made, the NCULPR will energize. That's the normal, called, route, and locked repeat relay. NCULPR. And that will enable a feed over the WZPR to release the RLR. Releasing the RLR will cut the feed to the WZR. And once the RLR is down and proved down, then a feed will pass through the NLR pickup coil. So to move the points, the RLR is released and then the NLR is picked up. And the NLR and RLR are used to drive the points on the ground. Within the track sets, such as a point set, there is also route and track indications. The route indications indicate the status of the calling and locking relays, whilst the track occupation lights, the red lights, indicate that the track is occupied. So once the route is initially called and locked through a set of points, then subject to the track being clear, a feed goes to the common lights on the left and to the normal right lights to the far right. The inner normal light doesn't light until detection is achieved with the NKLR, the normal detection lock relay, and that enables the other light to light. So when the route sets, if the points need to move, the signaler would see the common lights on the left, the normal lights on the right, and a gap whilst the points are moving. Once the points have moved and detected, then the gap will be filled in. So after what was quite a hectic bit of trying to call and lock the routes, the next step will be to move on to clearing the signal. But before that, we will need to reset the push button interlocking as well. So that'll be in the next video. I hope that has made some sense. Just remember, there's the 3 relay sequence for each of the track sets. The UZR that drops, that enables the CUR to pick up, which enables the LUR to drop. And then the process is repeated in the next set. And if you're in the relay room when the route is being set, you can hear that clatter. The dropping of the UZR, the picking of the CUR, the dropping of the LUR in a set, and then the process moving on to the next set. And the route lights will follow that process as well. So if the route lights only go partway through the route, then that tells you where the problem is. It's between the last set of route lights and the next set. And you can look at the UZR, CUR, and LUR to understand the problem. See you next time.